So today we are going to solve this Leetcode problem 416, partition equals subset sum. So the problem is given a non-empty array containing only positive integers. So we have to note that we are given only the positive integers here. Find if the array can be partitioned into two subsets such that the sum of each element in the both subsets are equal. Okay, and if we take the note, each element of the array each of the array element will not exceed 100. Okay, so we have positive and they will not never be more than 100, and the size of the array is 200. Okay, so um, okay, now if we see the example, we have 1 5 15 and 5. Okay, so the one way to partition the array is 1 5 and 5, which sums to 11, and another is 11. So we can actually partition the array into two subsets and sum of them is equal. In the second case, 1 2 3 and 5, there is no way, no partition to 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 equally divide the array. Okay, so what can we do? So the first, I think the first and the most brute force approach would be to generate all possible subsets. So we generate all possible subsets of the array, like the one subset. So the rest of the element would be in the other subset, and uh, we try to calculate the sum and make them sure that if they are equal or not. So one thing here is that we don't need to return the subsets, we just need to return true or false. So yeah, so the first approach is going to be to generate all the subsets and calculate this respective sum and check if they're equal. If they're equal, then we return true. Otherwise, after checking all of the subsets, if we doesn't have the equal sum, then we return false. So 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 the approach, so if we take this approach, what would be the time complexity? So we know that the number of subsets in a of an array with n elements is 2 to the power n. So to calculate this 2 to the power n subsets with n being the size of the array, so n is 200. So the complexity, the number of subsets would be 2 to the power n, which is a very huge number. So even though our solution for that for this problem, the approach that we have, like the brute force one, that can solve the problem, but it is not very efficient. So we need to find another way to solve the problem efficiently. Okay, what can we do? So one thing we can note is that the restriction we are given, then the array element is will not exceed 100. So if we have 200, so the sum of the element can be at max 200 into 100, which is 2 to the power 4. Okay, so this would be the maximum sum that we can have for the all number element. So the half of this can be the maximum if there is any equal. So 10,000 10 to the power 4 is the maximum equal sum we can get. Okay, now what we really care about is that, is there any way? So first we need to think if it is possible to partition the array. Let's say if the sum, let's say we define S is the sum of the array. Okay, if the sum of the array is odd, let's say 3 or 5, you can never partition the array into two with equal sums, because one of them is going to be different. So one is going to be the odd and one is going to the even. So there is no way, if the sum is odd, there is no way to partition the array. Okay, so that is going to the first one. So after we calculate the sum, we need to figure out if there is any subset which equal to s by 2. So first we check if the sum is odd or not. If odd, then we return false, otherwise it is even. So this is going to be a integer number. So, and what we need to find out is that if there is any subset that sum equal to the s by 2. So how can I do that? If you are familiar with dynamic programming, it is a typical dynamic programming problem. So you are given n numbers and you need to find a subset of these numbers that equal to a given sum, let's say x. Okay, so how can we solve the problem with dp? So let's say dpi equal to true let's say dpn comma m equal to true if there is a subset with first n minus with okay, index, let's say a is the array, so array 0 to n, including if there is a subset from 0 to n with sum equal to m. So how we going to have the how can we find a relation to calculate this dp? So to solve the problem with dp, we need to use the previous calculated value. So how can we find the structure, the recurrence structure to formulate the dp? So one thing we can say, the dp in m is true if so let's say dp n minus 1 and m is true if dp n minus 1 is true. So if we can find a sum of m without using the current element, we just, that's fine because we have found already a subset. Otherwise what we are going to use the current element, right? So the one thing we can do, if dp n minus 1 m minus array of n is true, so what we are going to do is that we are going to use our current element, the nth element, like the an, we are going to ns is included. So we need to check if there is any this value. So if we can make a sum of m minus a to the an with the previous elements, and we just add the an after that. So this is going to be our recurrence relation. So we'll have some base cases, but I think the base cases are very easy to figure out. Let's say that, so dp minus 1 0 is true because as the indexing starts from 0 in C or C++ or any most of the programming languages. So we need to like somehow handle this thing, or we can have another approach to handle the basic cases. I think that should be okay. I think that should be all right. Okay, now to code the problem. Okay, so first what we do is that we calculate the sums. So integer sum equal to 0. Okay, so we check auto x in nums sum plus equal x if sum percentage 2 equals 0. If not 0, then we return false. Otherwise, integer target is equal to sum by 2. So that's the target. If odd, return false. So this is the target. Now we need to figure out how we can make the target. So our last goal, if dp, so dp, the last one is if dp n minus 1 and x is true, then we return true, right? So let's say for I equal to 0, I less than n. Okay, so we need to declare this dp array. So let's define it here. Vector of a boolean. Okay, the first dimension is the number of size, and the second one is x or target. Let's call it x to make it x x plus 1, because we need to have the plus 1 to match the x, and let's initialize them as false. Okay, now so we iterate over the num dot size I plus plus. Okay, so and then we also iterate over all the value integers say equal to 0, say less than or equal to x, j plus plus. So one thing we can do here is that we can make, let's not complicate things. Okay, so let's call it dp ij equal dp I minus 1 dp I minus 1 j minus 1. But the problem is that if I is 0, this is going to throw an error. So we check if I greater than 0, then we use that information. Okay, and then we have to check if the j is greater than nums okay. Another thing we can do, if j greater than or equal to nums I, so we have two cases. If dp I minus 1 j minus nums I, then we set dp ij to be true. But what if the I minus 1 is not there? So if I greater than 0 and this is a condition, or j equal nums I. So we have two conditions. If we have a previous element and this is equal other, and other is so this is the first element of the subset that we are considering. So we have two cases. So after that we just return dp nums dot size minus 1 and x. Okay, let's try to run the code. It says that initialize kind of operation. Okay, this is j. Okay, so it works for the true cases. Let's try to modify it. So 1, 2, 3 and 5. It shouldn't return true. And let's try 6. It seems that the code is working, and we can try to submit it. So it accepted. Okay, so as you can see, it's not very fast compared to the other solutions that we have. So how can we make it faster? Okay, so let me do some optimizations here. So one optimization would be to the memory optimization that we have. So we can use less number of memory. So if we check the solutions here, and what we can do, we can actually, we just need the state of the previous array. So we don't need to store all the dp array, like the two-dimensional array. We just need the previous row. So we can actually have the previous row only, and without using the previous row. So if we use only the previous row and the current row, so we need to maintain two two arrays, two rows. But there is another way that we can optimize it. So if we try to calculate the values for, so if we calculate these j values in the reverse order, we are not going to use the current j value. We are going to use all the so let's say j equal to 10, and then we calculate 10, 9, 9, 8 and 7. So in this way, if we calculate this way, so to calculate the j, we are going to use some j which is smaller than this j, like the current 10. So that's this way we will never use the updated value in this round. So the way that is going to be like, let's define vector of vector bool dp x plus 1 with 0, and then for integer I equal j equal to x, j greater than equal to 0, j minus minus. The same thing, if I greater than 0, then dpi j equal to then we don't need to actually modify it. And otherwise, because this is already, so dp j or equal dp j minus nums I. We need to check with if j greater than or equal to nums I. And one thing we can do is that we say the dp0 equal to 1. So that's the base case that we have. And yeah, so in this way we just return. And another thing, optimize another, if dpx and then return true. We can terminate quickly, you see. So let me run the code. This is okay. So we can check the, this is also true because 7 and 7 we can make it. Okay, so let's try with this one. Let's check. Okay, so yeah, that's an improvement, like from 350 to 200. What else we can do? I cannot think of any good optimizations currently, maybe with the input output, but I think that's the good solutions that we have with the current setting. I hope you like it, and thank you.